All right, for number 39 and 5.3, I'm going to be dealing a bunch with one particular equation, so I'm going to write that out. I have here an equation that's P0 y double prime plus P1 of x y prime plus P2 of x y. And this is going to be equal to various things. So I'm going to call this whole object here star. Okay?
Cool.
Okay. And I am supposed to suppose that yp1 solves star equals f1 of x. Okay? In other words, I found some solution for some external forcing. Cool? And then I'm also supposed to suppose that yp2 solves star equals f2 of x. Right? And then they've asked for me to prove that yp1 plus yp2 solves star equals f1 of x plus f2 of x.
Is this proving the superposition?
Yeah, this is identically proving the superposition principle. You guys with me on that?
Is this like, for example, like, is this all the proof you would need if you're going to be like, hey, I discovered a new theorem, like blah, 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 and bring it to a math, place? Like, is this what they
Like bring it to the world of math place? Yeah, and then they'll check it for you and tell you whether, no.
Temple up in the mountain somewhere. Like.
Yeah.
The monastic order of the math place.
Essentially, yeah. So you would find some little bit of math, and then you would maybe demonstrate a proof of such a thing, and then what you would do is you would try to get your proof published or get someone of some standing in mathematics interested in said proof to look at it. And then they could, of course, direct you where to publish such an object. Yeah, that's basically legit. There are not so many of these left that are easy.
Yeah.
Okay, so in order to prove this, right, like this is my goal, is to prove this thing. So I think I probably should think about what it means for something to solve a differential equation. How would I go about trying to check whether yp1 and yp2 solve star equals something?
I mean, if you can get to a 0 equals 0.
Yeah, I basically need to start with something. I don't know. In this case, I have something that I think is a solution to star equals f1 plus f2, right? So why don't I start with that thing and star and see where I can get. You guys cool with that? So I'm going to start with yp1 plus yp2. So I'm going to say let y be yp1 plus yp2. Then what's y prime?
yp1 prime plus yp2 prime.
Y.
Rules.
I don't know.
Because, duh, that's how differentiation works, right? So, if you were writing a formal proof, you would say, okay, let y be yp1 plus yp2. Then y prime is yp1 prime plus yp2 prime, because that's how calculus works. Cool. So, because calculus.
You could probably shove that into the limit definition.
Sure, you could go all the way back to the limit definition of the derivative if you wanted to, or you could cite essentially an earlier work that's known to be true, right? You don't have to go all the way to the ground with this thing, right? You can just rest this on something that's already established. So I'm going to rest this on Calc 1. Alternatively, you could say because the derivative is a linear operator. That would be another valid statement today. And then also yp or y double prime should be
Same thing. Just double prime.
same thing but with double primes. Yp double prime plus yp2 double prime. And that's also because calculus, right? Good with this? Okay. So then where do I put those?
Into star.
Yeah, so I'd want to put those into star. So I'd say substitution into star yields. Right, like, in other words, if you cram these into star, what do you get? I think you get P0 of x times, what was y double prime?
Y double prime P1 plus Y double prime P2.
Y P1 double prime plus Y P2 double prime. Okay, so then what? Plus P1 of x. And then I need a yp1 prime plus yp2 prime. Guys with me on that? And then I need a plus p2 of x. And what was y? yp1 plus yp2. Okay, do I know what that equals yet?
I mean, we're supposing what it equals, but we're not even knowing.
Yeah, so I want to prove that it equals f1 plus f2, right?
Well, it's pretty much already proven, isn't it? Because asterisk is equal to f1x, and asterisk is also equal to f2 of x.
So this solves the asterisk or the star equals f1, right? What I don't know is that this sum solves as the star equals to this sum.
Oh.
I don't know that yet, but I think I'm really close. You guys see this? So why do I think I'm really close? What do I think I can do with this then?
Distribute and regroup.
Yeah, I think if I distribute and regroup,
Oh, we need to mark it that one.
so distribute and regroup to C. And really I'm doing here star evaluated at y equals yp1 plus yp2, right? You with me on that? And that's going to equal, so if I distribute and regroup, I'm going to get P0 yp1 double prime plus P1 yp1 prime. Oops, I forgot of x's here. Putting of x's as appropriate. Plus P2 yp1. So that's the first term out of each thing. All right, so I got all that stuff plus. And then what's in the second one?
Same thing with P2s.
Same thing with yp2s. So I got P0 yp2 double prime plus P1 yp2 prime plus P0 yp2. And then what do I say?
Could you say that left one's F1 and the right one's F2?
Yeah, exactly. So I need to cite these two things, right? So I might off in the margin call this one suppose 1, and I might call this one suppose 2. Like, I don't really care how you cite these. Like, various books will do various things. Your differential equations book does what? How does he cite lines?
Capital letters.
Yeah, he cites lines with capital letters. He'll say, so referring to B or referring to D. So however you do that, you just need to mark a spot, right? So I'm going to say referring to suppose 1 and suppose 2, right? Observe star evaluated at y is yp1 plus yp2 equals f1 of x plus f2 of x. And that's the definition of what it means to solve this differential equation. You guys see that? So once I'm there, I do this thing. Box been done. So,
On the on the bottom where it's star evaluated at no, to the right. Yeah. The second group, is that supposed to be P0, P1, and then P0 again?
oh no. It's supposed to be P0, P1, and P2.
Okay.
That was just bad handwriting. You guys with me on this? So my flow of argument, right, is first I'm doing all this letting, then I'm doing this substitution into, then I'm doing distribute and regroup, and then over here I'm concluding my thought by noticing that that means that this is solved. That's cool, that? So a proof in formal structure, right, is a list of suppositions, then some kind of mechanics, and then an observation at the end. It's cool, that? Probably have not seen too many of these, right?
Well, it would be probably easier, right, if you were doing these with like actual values.
It would definitely be easier if I was doing this with actual values, but this is how you get theorems, right? So this means that we now know that the superposition principle is true. And so now we can go ahead and use the superposition principle whenever we want without going back and checking that it works.
So I get this proofs of superposition, but why doesn't it include the homogeneous solution?
So the homogeneous
Or
solution
is that just 'cause-
is this for f1 of x is 0. Right, so normally, like when I first started solving these, I'm going to calculate the homogeneous solution, right? And then I'll add it to the particular solution.
Yeah.
And there was maybe only one particular solution. That was f1 of x is 0 and f2 of x isn't. So then this yp2 would actually be a particular solution, and yp1 would actually just be the homogeneous solution.
And the general will always have that because there's always a 0 sign.
Yeah, and the general always has the homogeneous part in it because you can always add a 0.
Okay. So we could have like, okay, and then it was including the homogeneous, and we had yp1 and yp2, it would just be like yp3.
Yep.
Okay.
Yeah, so if we had a bunch of things added together, right? Like if we were trying to solve star is f1 of x plus f2 of x plus f3 of x plus f4 of x plus 0.
Then
Right.
you have like.
We have
four
yp1, yp2, yp3, yp4, and y homogeneous. You guys all good with that? And the way we'd prove that, right, is we'd just apply this thing a bunch of times. The first one would be to f1, and then f2 would be f2 plus f3 plus f4 plus the 0. And then we'd apply it again, and apply it again, and apply it again. That would be kind of finite induction. Let's call that.